All right, I'm back. We're on page 285 now, and we're talking about intermediate value theorem. We talked a little bit about the intermediate value property, which is not something you're really responsible for, but it's kind of an interesting factoid that applies to some functions. So what we want to do now, use the intermediate value. So this is the main use, really. Well, it's not. This is not the main use. The main use is to show that a function has a zero, which we'll get to in a second. But we want to use it to prove that cosine of x equals 0.25. Prove that cosine of x equals 0.25 has at least one solution using the intermediate value theorem. So graphs can be incredibly useful when you're trying to determine these things. So let's just graph cosine, which, we've done about 300,000 times. So here. I often, after I say something like that, then get things wrong. So I hope I'm not doing that right now. Here, and there. Okay, so that's a graph of cosine. So all that I need to do, so 0.25 is going to be like, let's say, like here, right? All right, so I want to show that this thing definitely has a solution. So how can I do that? Well, I don't need to be super precise. I just need to show that it has a solution. And so what I'm going to do is I'm going to say cosine is a continuous function because that's required. So cosine of x is continuous on, all right, what interval do I want to use? I think 0 to pi over 2 is a plenty good interval, so I'm going to do that on the closed interval from 0 to pi over 2. If you wanted a more accurate thing, then you could do like pi over 3, right? The cosine of pi over 3 is 1/2. That's bigger than 0.25. Cosine of pi over 2 is 0. That's less than 0.25. That's a smaller interval, and it's like a little more precise, but like we don't need that. We just need to get an interval and show that it is true. It's continuous on this. All right, let's say the cosine of pi over 2 equals 0, and the cosine of 0 equals 1. Ooh, I don't know how I did that. It's like I made a really straight line. It like just did it itself. Equals 1. All right, so so cosine of pi over 2 is less than 0.25. It's less than the cosine of 0. Therefore, by IVT, cosine of x equals 0.25 for some x, and then I'm going to do comma 0 less than x less than pi over 2. All right, so it's intermediate value theorem. Continuous on the closed interval guarantees a solution on the open interval. That's a big deal. So continuous on the brackets closed interval, and then the solution will be on the parentheses open interval. That's always going to be the case, and this becomes really important. Like you're going to start seeing things where you know the answer, obviously. It's all about how you write it up, and you have to be really specific in the way you write it up because the people who look at that are really specific in the way they grade it. So make sure that you are on top of that stuff. All right, IVT, an existence theorem, right? It tells you that something is guaranteed to exist, doesn't necessarily tell you how to find it. Oftentimes, bizarrely, that doesn't really matter. You just want to know, is it there? Like, I don't need to find the white whale. I just need to know that he's there, type of thing. This is the exact opposite of how Moby Dick works. So really, it's a terrible book. I do not recommend you ever read it. It's like 300 pages about like the whaling industry, and then like I don't know how many pages of an actual story. But read it if you want to. Don't let me talk you out of that. All right. If f of x is continuous on a closed interval a, b, and if f of a and f of b are non-zero and have opposite signs, so there's what we call a sign change, goes from negative to positive or positive to negative, then f of x has a 0 in a, b, in the open interval from a to b. That's the intermediate value theorem. That's how you use it like 90% of the time. Also, I think this has a name. I think it's like Bolzano's theorem or something like that. I don't know. Wikipedia, see what it says. I think that's what it's called. But like no one really cares about that, the specific name, because I guarantee you there's some, in other cultures, there's a different name being used for it. So it's like the name doesn't matter. It's the concept that matters. All right. So how can we use this? Well, this seems like a calculator question, so I'm going to actually use a calculator on it, but show that this function has a 0 between 0 and 2. So like my hope would be that at 0, I get a positive, at 2, I get a negative, or the reverse. At 0, I get a negative, and at 2, I get a positive. I'm hoping for that because I'm going to start off writing my solution. I'm going to say f of x is continuous. It is continuous on the closed interval. How do I know it's continuous? It's a trig function minus a trig function, and both those trig functions are continuous. So like it's continuous. So it's continuous on the closed interval from 0 to 2. All right, let's go to the calculator and see what we get. So share, switch it up, calculator. You can see our old calculator problem here. I'm gonna go new problem. And all right, so should I graph? I'm not gonna graph. I'm gonna go straight calculator. F of x is, so cosine squared, you wanna do cosine of x, get out of the parentheses, squared. You already know that, hopefully. If you don't, oh my God, I don't even know. X over 4, all right. Gotta be in radians, everything we do, radians from here on out. Been that way for a long time. Basically triangles are the only place, I guess, that you really want to be in degrees. All right, so f of 0 is 1, so that's good. It's good if f of 2 is negative. It is. Okay, so f of 0 is positive, f of 2 is negative. Therefore, by the intermediate value theorem, f of x equals 0 for some x between 0 and 2. So I'm going to go back to the notes and I'm going to write that up because that's important. So do I need to say the specific values? Open question in mathematics. Not 100% sure. I'm going to do it because I think it's important. So I'm going to say that period f of 0 equals 1. F of 2 was approximately, let me go back to my calculator. I'm not going to make you look. Negative 0.786. Negative 0.786. Okay, so we got our setup. Okay, so how can I say this? All right, so f of 2 is less than 0 is less than f of 1. No, f of 0 is 1. I get confused like that sometimes, so this is true. Therefore, by IVT, ooh, what is that? That's gonna be impossible to erase because it created like 1,000 lines. By IVT, f of x equals 0 for some x, we don't know what x, some x, and I'll go with the element of thing, element of 0, 2. I could have done x comma 0 less than x less than 2. They're both totally valid. It's up to you. All right, now it says use 2 iterations of the bisection method. So what I currently have is like, I know that the 0 is somewhere between, so what should I say? F of c equals 0. So I started off with c is between 0 and 2. I'm going to find the midpoint of that, which is 1, and see what f of 1 is. So let's go to the calculator. F of 1. Okay, f of 1 is negative, which means that 2 was the value, see, you can see here, 2 was the value that was giving me the negative. So now my interval is between, so it's an open interval. This doesn't make any sense. This is going to give me an error, but the interval now is between 0 and 1. Somewhere between 0 and 1, there's a 0. And syntax error, obviously. Oh, you know what I'll do? I'll put it in, here we go. Somewhere between 0 and 1. F of 0 is positive. F of 1 is negative. Somewhere between 0 and 1, there's a 0 for this function. Okay, the midpoint of that is 0.5. Let me find f of 0.5. F of 0.5 is positive. Okay, so f of 0 to f of 1 was like positive, negative. Now f of 0.5 is positive, so I shorten it between 0.5 and 1. So bisection method is going to give me this interval. Somewhere between there is a 0. Now let's see if that's true. Solve f of x equals 0 for x. Let's make sure we're on the interval. So between 0.5, there's no guarantee it's going to be able to solve this. It has a lot of trouble with like tons of trig functions. There we go. So we got a solution. It's also probably telling me that more solutions might exist. more solutions may exist. But all we needed was 1. So bisection method, if you're going to write this down, you go from 0 to 2 to 0 to 1 to 0.5 to 1. Guaranteed to be a 0 somewhere in there. Okay. I think I'm going to finish this page in this video because I feel like I can. I feel like if you're tired, you could pause this, take a nap, come back. Hopefully you're not watching this at like 3 in the morning, like my students are reporting that they're doing things. Gotta have a regular sleep schedule, people. Like, follow a schedule. Get up a certain time, do something, have breakfast, maybe go to some classes, do some work, whatever. All right, let's see. Function f is continuous. Okay, with only one relative extrema. So now I'm throwing extra information in there. What's a relative extrema? So a relative extrema is either a maximum or a minimum. So that's all it means. It's a relative extreme value. What's extreme? It's the maximum. It's the minimum. Those are extremes on the interval from -2 to 5, occurring at x equals 3. Oh, we know where it happens. Okay. Find the values of k that guarantee f has a, 0 roots, b, 1 root, c, 2 roots between -2 and 5. One of the things when you have tables that I would like to encourage you to do is plot things. Get used to it. The more you're used to it, the more likely you are to do it. So let's start with, we're going -2, 3, and 5. Okay, and I know that it's going to be at like 4 and 8 and somewhere. All right, I want to make sure that I have no roots whatsoever. So that means the graph could never cross the x-axis, but it's already above the x-axis, which means it needs to stay above the x-axis. So if I do anything like this, like this, like this, like this, like, so it only has one relative, oh, it has to have a relative extrema, actually. Some of these are not valid. Let me erase some of these. This has none. That actually does, I suppose. All right, but if you look at this, you kind of get the general sense that if you're going to get no zeros, you need k to be greater than 0. And also, there's a k value that it can't be. It could never be whatever. We don't need to overthink this, but it could never be whatever k value you would get for a straight line, because a straight line has no maximum or minimum, right? It's just, there's nothing there. There's actually probably a lot of them. Am I overthinking this? I mean, probably. I tend to do that. I actually think you need to be, I should not have started this problem. I think that you need to be below. Okay, so let's do this. I think I have a better answer. I'm not going to prove it, but I think that this is true. Think it through. Think a lot. Try to draw some. Remember, you can only have one relative extrema. I think the answer to this is, so no zeros and one relative extrema. That's the key thing. I think you need to be between 0 and 4 or greater than 8. I think as long as that is true, you have met all of the criteria. Somebody let me know if they think that is true. I don't really know. I think that that's true. All right, 1 root. I'm confident in this one. So for only 1 root, -2, 3, 5. You're up here. You're down here. Am I gonna have enough space? Being really aggressive with how much space I'm giving this. Hold on. Let's move you over. Okay, that's it's better. All right, so if I'm gonna have no exactly 1, there's actually only one option for this. So I have to make sure that this happens because I'm only allowed to have 1 relative extrema. That's gonna have to be it because I can't go lower than that because then I'd have 2 zeros. So I must have to hit exactly there to make it work. So I'm gonna say that, so 1, 0 is gonna be k equals 0. If k is equal to 0, then you're gonna get exactly 1, 0. And then the next one, it's like, you know, you probably have a sense of it. -2, 4, 4. 5. Can I do it? Yeah. And 3. So you're here. You're here. I need to have 2 zeros, 2 roots. So I'm going to have to swing below the axis and come back up. So, and I think we can do that for any value between, so 2 zeros. If you don't cross it, it's a 2. So that's how you know that's a 2 and not a z. 2 zeros. I think I just need k to be less than 0. As long as that's true, I think that'll work. All right, you know what I'm going to do? I'm going to stop this video here, and I will see you in the next video, in which we will do even more stuff. So I hope you still are fine. If you ever were, I hope you are still finding these helpful, and I'll see you then.